This is section 4.5 of AP Microeconomics. Let's get started. Well, this is the last of the market structures for imperfect competition. These are oligopolies. And with oligopolies, you want to think of just a few firms that dominate the market. Interdependency is very important with oligopolies. It means one firm's decisions impact another's. Of course, they're price makers. They do have a lot of market power, and they have very high barriers to entry. We'll talk about cartels in a minute. Some examples of oligopolies are cell phone service providers, of course, and cereal companies. There's only a few things you need to know about this. First off, we're not going to do any graphing. All the graphing for imperfect competition is the same, but we're going to focus mainly on game theory. So there's a few things you need to know. First is, what is a cartel? This is when members collude or cooperate to gain monopoly power. Of course, it's illegal. So imagine the cell phone service providers got together and decided on a minimum cell phone monthly plan of $1,000 a month. That would be a problem. They can't do that. What we're going to talk about now is game theory, and that is just a study of how and why people make decisions. There's a few main things you need to know about game theory. One of them we talked about, what collusion means. Second is the most important one, that is a dominant strategy. A dominant strategy is just a choice that a firm is going to make regardless of the actions from the other firm. Think of it as in like a game of chess. If it does not matter what my next opponent's move is, I already know what move I'm making, that would be a dominant strategy. Nash equilibrium is a little more difficult to understand. That's just a position within the matrix where neither firm can better their position. So each firm is in the best position given the actions of another firm. So let me show you how to do each of these three. The first thing to notice is that these matrices are in color. On your test, they'll be in black and white. So we want to get used to knowing which number goes with which firm. The number on the left goes with the firm on the left, and the number on the right goes with the firm up top. That's true in every cell. Second, you need to know what the numbers represent. Most of the time, they're going to be profits. On occasion, you could see a situation like prisoner's dilemma where the numbers will represent jail time. So the lower number would be better in that scenario. But here we're going to focus on profits. Let's start with the first one. Does either person have a dominant strategy? Well, I like to circle these, so I want you to visualize me circling these. Let's look at it from Al's point of view. If Cal decides to open on Sunday, Al would rather raise his prices. If Cal decides to add a car wash, Al would rather raise his prices. So it does not matter what decision Cal makes. Al is in the best position possible to raise his prices. That means Al has a dominant strategy to raise prices. Let's look at it from Cal's point of view. Well, what if Al raises his prices? Cal would be better off, $3.95 versus $90, opening on Sunday. What if Al lowers his prices? Which position would Cal be in the best position? Well, once again, open on Sunday. Since no matter what decision Al makes, Cal's going to open on Sunday, that would also be his dominant strategy. So it is possible for neither firm to have a dominant strategy, or only one of them to have a dominant strategy. In this case, both of them have a dominant strategy. Now, is there a Nash equilibrium? Okay. And again, a Nash equilibrium is where both firms are in the best position given the actions of another firm. The good news is when you have two dominant strategies, they will tell you where the Nash equilibrium is. It's a nice shortcut. I'll show you in a minute how to find it without the shortcut, but it would be to raise prices and open on Sunday. So this would be your dominant strategy, meaning neither firm can better their position. Now, what if they colluded? What decision would they make? Well, remember, when you are colluding, you are acting as a monopoly. You're going to look at the best interest of the firm as if it were one. Well, that would be selecting the cell with the highest combined profit. So Cal should add a car wash. Al should lower prices. This cell gives us the highest combined profits for our monopoly, which means this is the cell you're going to choose. If there are multiple cells with the same total, you're going to choose the cell where the numbers are closest together. And that would make sense because why would either firm choose a cell where they're giving up most of the profits to the other firm? Again, this is illegal. So you want the cell with the closest combined profits. Now, let's look at this last one here. Does either firm have a dominant strategy? Well, I'll tell you they do not. Because if Tiny opens a new location, Biggie would be better off buying ads. If Tiny provides free delivery, Biggie would be better off buying new capital, which means Since Biggie will change their decision based on what Tiny chooses, Biggie does not have a dominant strategy. I'd like you to try the dominant strategy from the perspective of Tiny, and I will tell you, you will see there would be no dominant strategy. What decision would they make if they collude? Well, if they collude, where's the sell with the highest combined profits? Right here, $34, which means this would be their decision. Last but not least, Nash equilibrium. Well, without dominant strategies, you might think Nash equilibrium would be difficult. It is not. What we're going to do here is we got to find the sell that puts each firm in the best position possible. Now, it is possible to have two dominant strategies. It is possible to have none. It's possible to have one. Obviously, you can see the answer that there are two dominant strategies here. Okay, well, let's take a look. So what I'm going to do is see if I can circle this here. Let's look at it from Biggie's point of view. If Tiny decides to open a new location, Biggie would rather buy ads, which means since Biggie is in the best position here, this cannot be Nash equilibrium. Well, what if Tiny makes this choice? Biggie would be in the best position up here, buy new capital, which means this cannot be Nash equilibrium. Now, what if we do it from the other perspective? Okay, let's go this direction. Well, now, if you're looking at it from Tiny's point of view, 16 versus 24, Tiny would rather make 24, which means I'm going to cross this out again. This cannot be Nash equilibrium. What about this one? 8 versus 4. Well, Tiny is in the best position here. So again, if I were to go this way, Tiny would be in the best position here, which means this, once again, is getting crossed out. So once you do that 4 times, whatever cells are left standing are the cells within Nash equilibrium. In this case, there's 2 of them because in those cells, neither firm can better their position, and that's why this trick works. Okay. Well, that's it for Unit 4.